Hello, fellow classmates. Welcome to my lesson on lubrication and sliding bearings. My name is Gabriel, and I hopefully will teach you something today. The three primary points of interest in this lesson are the types of lubrication, anatomy of journal bearings, and the relation between Petrov and Raymond Boyd charts. Raymond D. Boyd charts. So, first off, the types of lubrication. When talking about lubrication, there are three main types that we must consider. Among these types of lubrication, generally speaking, there are two surfaces separated by a film of oil or lubricant. First off, we have hydrodynamic lubrication, which consists of a surface completely separated from another, thanks to the lubricant film. In this instance, surface wear does not occur since the elements aren't coming in direct contact with each other. And usually, the film thickness for hydrodynamic lubrication can have a minimum value of 0.008 to 0.02 millimeters. Corresponding friction coefficients stretch from 0.002 to 0.01. Second, we have mixed film lubrication. This type occurs when surface peaks of a material are in intermittent contact with another. This results in possible mild wear, but more often than not, there will be relative amounts of wear. Corresponding friction coefficients range from 0.004 to 0.1. Finally, we have boundary lubrication. This occurs when surfaces of the materials are in continuous and extensive contact throughout all cycles. Throughout the active wear here, although the active wear here is greater than that of the other types of lubrication, a light film of lubricant is still expected to reduce wear. Now, if you'll notice, the types of lubrication that I've just mentioned are in order of least friction to most friction. Since hydrodynamic lubrication offers the least amount of friction between the journal and the housing, it just decreases from there, or increases rather. The anatomy of the journal bearing. The journal bearing. The journal bearing consists of a couple features, which we should get familiar with. First and foremost, the housing, as we just mentioned. The housing is the outermost part of the journal bearing, and it retains all lubricant, solid parts, and forces inside of itself. Second, we have the journal itself. Yeah, that's right. We're not talking about books, as it's quite the opposite. Instead of it being a multi-folded paperback quadrilateral, it is rather a metal, cylindrical shaft that transfers load and forces from one surface to another. In between this housing and journal, we have a bearing liner, which is meant to keep the journal on course and reduce lateral deviation. And between that and the journal, we have the bearing clearance. This empty space will be filled with a lubricant and will result in either hydrodynamic lubrication, if the journal is spinning fast enough, or boundary lubrication at relatively slower speeds. A spinning journal results in pressure and journal buoyancy. When attempting to analyze the functionality, efficiency, lifespan, or the overall specifications of journal bearings, we have two methods of doing so. Petrov's equation helps us determine any of the following variables using this formula right here. Friction torque, viscosity, shaft rotation speed, length of the bearing, radius of the journal, and radial clearance of the bearing. Likewise, we can also use Petrov's other formula to find the friction coefficient of the journal inside the bearing. Unlike Petrov's equations, the Raymond-Boyd charts are used to find relations between specific physical numerical entities. For example, from a ratio of length to diameter, which we can use on all of the charts, we can relate the bearing characteristic number to any of the following: minimum film thickness, coefficient of friction variable, minimum film pressure ratio, position of minimum film thickness, terminating position of film, flow variable, and the flow ratio. From all of the relations, we can solve for any number of variables. We use the Petrov and Raymond D. Boyd methods of analysis to investigate the workings and conditions of journal bearings. Thank you, and I hope you learned something.